Good morning. Today we're going to be solving polynomial equations. It's winter and I have a hat on. I'm going to I'm going to say something and just repeat after me. If you feel... Ready? I actually wasn't prepared for that. If you feel, go ahead.
If you feel...
Ready to start math?
Ready to start math?
It's time to reinvent the system.
It's time to reinvent the system.
No longer will we be intimidated.
No longer will we be intimidated.
We're going to go with a positive attitude.
We're going to go with a positive attitude.
And we're going to realize it's not that hard.
And we're going to realize it's not that hard.
Capped off by one statement.
Capped off by one statement.
Yay math?
Yay math!
Okay, see, now we can do it light and fluffy. Okay.
That was so much.
Yeah, dude. Amen.
Amen.
Alright, Alright, here we go. Okay. Factor time. The goal is to factor this. And there are several rules of factoring that we need to keep in mind. What's the first rule of factoring always, always? Look for the?
GCF.
What's it called?
GCF.
GCF stands for?
Greatest common factor.
Greatest common factor. So, is there a greatest common factor, a factor that can multiply into this, and this, and this, and that?
No.
No. Alright, so this is one of those situations when you have 4 terms, and many times in the 4-term one, we split it down the middle, alright? So that's kind of helping you spot different situations. So if you have a 4-term one, you may need to kind of cut it down the middle like this, and factor it in pieces. Now that we cut it in the middle, is there a greatest common factor for these two?
Yes.
What is that?
3A.
3A sounds right. So I'm going to write that here. 3A. Okay, so 3A is what's called factored out. And basically undistribute is the way I call it. So 3A times what is 3AX? X, very nice. Minus 5.
Shocker.
Okay.
Brilliance.
Very nice. And now, is there a greatest common factor here?
No.
No. But so what we're going to do is we're going to call it 1 for the purposes of this problem. So we're going to say, all right, right over the love spot, plus 1. Okay, just for the purposes of this problem. Factor out a 1. And will x minus 5 change inside here?
No.
No, it will not. X minus 5.
I see it.
Okay. Now, if you have 3a times x minus 5 and 1 times x minus 5, allow me to write the solution, then we'll talk. 3a plus 1, x minus 5. Okay. That's great. No longer will we be upset with the math. Amen. Definitely though, it's we're not picking flowers in the sunshine, I understand. But you know, at least we're gonna go on a field trip for flowers and sunshine and bring a whiteboard. Okay. That to me is, that's a vacation, right? Did you bring the picnic? Did you bring the blanket? Did you bring the whiteboard and dry erase markers? Yeah. Yay math, yay life. Anyway. So now, check it out. If we're doing a foiling system, would you agree
It works.
that 3a would be multiplied by this, then that? Right? That's foiling. 3a times this, then that is here.
Right.
And then we'd switch to 1. 1 times this, then that is here.
Yeah.
And now if we FOIL it out, you'll get 4 terms, and here they are.
Yeah.
So that's 4-term factoring. Questions?
No.
Wait,
Yes,
how
please.
did you, get that third step done?
This one?
Yeah.
Okay, good.
I understand the foiling, but I don't
Cool. Notice the x minus 5 is common,
Yeah.
so that we can pair the 3a and the 1 together,
Ah.
times their common x minus 5. Yes?
So the bottom is the exact same problem as the top.
Exactly. This is called, the instructions would say factor this. This is factored. Factoring indirectly means make it into pieces that multiply. So this is a multiplication problem now. And if you were to FOIL this, F-O-I-L, you would get 1, 2, 3, these 4 things. Actually in order as well.
Yeah.
Okay. Questions further? All right, 2 more.
Was that it?
Haven't we done that before though?
We
Like
have.
that method?
I'm warming you up.
Okay.
Okay, now, the instructions may say factor, but it wouldn't only say factor, would it? What would it say?
Stop.
Yeah, it would say factor to solve, or use factoring to solve. Why would it say solve? How can you know it's going to say solve? Equals 0 is apparent, yes, sirs and ma'ams.
Wait, what, say it?
So, the instructions would say solve, meaning x equals something, because we have an equals sign. The previous problem did not have an equal sign, so it would not say solve. It would say simplify. Good. All right, so use factoring to solve. How many terms do we have here? 2. Is there a greatest common factor?
No.
No, so we skip that step. And now, if we have 2 terms, this could classify as what type of factoring problem? A what of what? Difference of?
Squares.
Squares. Excellent. So difference of squares. That's right. What are the perfect squares?
9.
So 9 is here, yeah, and
9.
X
not
squared.
2, say, yeah, x squared.
Oh.
X squared. So the square, or the square root of this is x squared, and of this is 9. So observe. Difference of squares follows this format. Okay? Equals 0. And then we have a plus, we have a minus. Difference of squares. First 2 terms are the terms that multiply by to make x to the 4th, and what are they? X squared and x squared. They have to be the same thing. So x squared and x squared. And the second 2 terms multiply to make 81. 9 and 9.
11.
Okay. And now, can you see that if it's FOIL, that it would be the same as the top?
Yeah.
Because the 2 middle terms will cancel. Observe.
Nine.
X squared times x squared is
4.
x to the 4 minus 9x squared
plus 9x.
plus 9x squared minus 9x squared plus 9x squared gone. 9 times negative 9 minus 81. Question.
Should we simplify it more, like after? Yeah.
Can this be factored more?
Yeah.
Which one?
Both.
X minus 9. X squared.
X squared minus 9. When they call it a difference of squares, I'm going to write
You
it.
can only do the one that's
Right.
Minus.
minus.
Love these little shapes. Difference of squares. So difference of squares means difference means subtract. So this cannot be factored. This can be factored. Because there's a minus sign, this is a perfect square, and this is a perfect square. Had this been an 8, for example, what if this was x to the 4th minus 64? So we would have x squared and squared. 64 break down to 8 and 8. Could we factor it then?
No.
X squared minus 8. Why not? Because 8 is
Not a perfect square.
not a perfect square. Questions on that?
Wait, yes.
We need each of these numbers to be a perfect square. Perfect square means something times itself.
Yeah, I got that.
All right? So if this number was 8 here, there's no number times itself that equals 8.
The part with Fusa is why can we ever do with a minus? It's not.
Because, yeah, that's a good question. Notice in here, because there's a minus, we can do it. When you do plus and minus, that creates the situation in which the middle 2 terms cancel. So then you'll have x to the 4th minus 9x, and now plus 9x squared. Minus 9x squared plus 9x squared, they cancel. I'll jot them down.
Because you want
X
to
to the
cancel
4th
the...
minus 9x squared plus 9x squared minus 81 equals 0. So now these 2 cancel each other. But if there was a plus, if these were both plus, for example,
It'd be...
then it would be
X to the
plus
4th
9x
plus
squared plus 9x squared. That would be plus 18x squared. That would be a middle term. We don't have a middle term. Right? So the minus plus create the middle 2 to cancel. That's the reason. That's why it has to be minus. Okay, so let's factor the second guy. Or girl. You know? Factoring is yes, co-ed factoring. Co-ed factoring. Let's be like a locker room. Welcome to the co-ed factoring locker room. where factoring is all male and female and mix, and animals.
Not animals.
Well, we could call this a dog. Here we go. This dog cannot be factored. What is the factoring of this horse?
It's gonna be X minus.
Everyone could say it.
X plus 3, X minus 3.
X minus 3,
Yeah.
X plus 3.
Because so.
But why would you do the minus first?
You don't have to do minus first. Good question. They're the same. Minus first or plus first. Yes,
Why
sir.
did we do x squared plus 9? Why did we write that again?
Because it's the same problem.
I know, but why did we factor the second?
We can only factor difference of squares, the minus one. So the plus one we can't change. So we left it alone.
Wait, so we can only do minus because the original problem is with the minus.
Yes, you can only do minus because the original problem is a minus. Correct. Now we're not done though. Once you factor it, what do you do to each factor? You what?
You have to
You have to solve.
Set it to 0. Yeah, so you have to set each factor. How many factors do you see?
3.
3 factors.
So.
So let's set each one to 0 in succession. Here we go.
I see. You have to do
X squared plus 9 equals 0. X minus 3 equals 0. X plus 3 equals 0. So there's all 3 factors set to 0. All right. Let's start with the easy ones. What would X be here?
3.
X is 3. What's X here?
Negative.
Let's write those. X equals 3, because 3 minus 3 equals 0.
Does the next one have I in it?
X equals negative 3.
Yeah, baby.
Mind reader.
X equals
Yes.
Can I try and do it?
I would love, that's great. Do that more.
3.
Elevator. Doop. Like that? It's power. There's a real elevator. Okay, go.
Okay, so wouldn't you subtract 9?
Let's subtract 9.
Yeah. That's a good idea.
I'm gonna, let's be creative.
Okay.
Watch this. We can do what we
Arrow,
want.
arrow.
I do what I want. Okay. X squared equals negative 9.
Okay, and then
I
you
do what I
square
want.
root.
Come on, Jordy.
What's
Square
that?
root.
Square both sides. Why did I jump up and down? I
So then it would be
Okay.
so then it would be x equals square root of negative 9, but you can't have a negative, so you take out I.
Okay.
So it's
I
I
comes
square
down.
root 9
So what's the
so
square root of 9? Okay, let's write it all together. Yeah, I square root 9 equals.
is 3I.
Okay, so we're
Or
missing
I.
one thing.
Plus or minus?
Oh.
Plus or minus.
Plus minus,
Yeah, whenever we
okay.
take the square, we're going to say
Right.
plus or minus. So say the whole thing together. The answer is
Okay, so
plus or
x-
minus.
So plus or minus 3I.
Very good. Plus or minus 3i.
Like plus or minus 3, plus or minus 3i.
3i and negative 3i are the answers. Is that your question?
No, but it's okay.
Okay, what's your question?
No, it's not a question.
Oh, okay. Oh, it's a statement?
Yeah.
Yes. Plus or minus 3i. And here's a preview for the thirsty minds that you are. Here's what I'm going to tell you, and we're going to talk about it in the next lesson, next video. What degree function is this? 4. Fourth degree function. It's an even function, all right? Again, degree is the highest power in the whole situation. And what you're going to see, which is a kind of an interesting find, is that the degree of the function, the highest power, is the number of solutions that exist.
Uh-huh.
The highest degree function is the number of solutions that exist. So how many solutions exist to this problem?
4.
4. Here they are.
But we only have
3,
No.
negative 3,
Plus
3i,
9.
negative 3i. There's your 4 solutions.
Come on, George.
Cool, huh?
That's
So highest degree is the number of solutions. Both combined real and imaginary. How many real solutions exist here?
2.
2. How many imaginary solutions?
2.
2. So those are your 4. Okay.
that's not all that.
Pretty cool, huh? Okay.
Next one.
Anything for a chuckle. I got one chuckle. I got one. One line at a time. Okay, last one.
2x to the 5th plus 12x cubed minus 54 equals 0. You ask, are you serious? Yes, it's serious.
So,
Are you ready to rumble? Let's talk. What was the first step in all factoring equations again? Look for the greatest common factor. Is there him?
No.
He is not there.
There is a 2.
Oh yeah.
There is a 2. You know what I'm going to do also?
What?
I am going to ask you, so I want to alter this a bit, to put an X here. Make that.
Oh yeah.
I'm going to put an X there. Yeah, let's put an X there. That'll make the point better. Okay, so what is the greatest common factor now? 2x. Excellent. Writing that in blue. Okay. 2x is factored out. Leaving us with what?
X
X to the 4 plus 6x squared minus 27 equals 0. Good. Questions so far? It's the last one. It's going great. Oh, by the way, before we continue, how many solutions will be here?
5.
5. 5 solutions.
Why is that?
Why 5?
The degree.
Highest power. What's one solution already? Can you see it?
X equals 0.
X equals 0. How?
2x.
Yeah, we're going to
2x
set
equals
this factor to 0, right?
Divide
So
2
this
by
is
5.
this is factored out. So that's going to be one of the factors we set to 0 at the end. But we can already see one of them is 0. And we can check that. If we plug 0 in here, 2 times 0 to the 5th, 0. Plus 12 times 0 cubed, 0. Minus 54 times 0, 0. It's all 0. So it works. 0 plus 0 minus 0 is 0. 0 is said many times, 0, 0, 0. Okay. 0. That's funny to me. It said it like 10 times in a row. Like, probably because you're concentrated.
Concentrated?
Yeah, I say it with the hard C's every time. I don't believe in. I make up my own language.
Okay.
Let's factor this. It's seriously true. It's like, why do they have it Cancun but call it Cancer? It's like, it's not fair. You know? Why do they call it, I'm going to Cancun next week? Sit in the sun. Yes.
What?
I should have kids.
I feel like a really
Cool.
good one.
Can
Not
I-
like right now.
I do have kids. Hi, kids.
Like your own kids, like bad, like you just lie.
That you could like teach them math on.
I have heard I'll be a good dad.
Yeah, you will be.
Yeah.
I have heard.
You'd be
Yeah.
like,
can do
like the
this.
stubborn, but not like too stubborn. And like,
Despite the jail time.
up here.
The guy.
Like my dad.
Hey, disclaimer, that's a joke. Yeah, I
And
have
you're
heard
gonna be
that.
so embarrassed.
I know.
You're like, Dad, you're like, Dad, stop.
I'd be like, can't wait to friend you on Facebook. Right on my wall. Right. I guess I'm doing that already. Dude, oh my God, can you imagine one day that they're going to be watching this?
You'd be like, Daddy, shocker.
You like my hat, son?
Like one day,
What if it's a girl?
Like your kids will ask like what your dad does, and they'll be like, oh, he has a math website.
Math website.
Created new math.
Are you going to be like all the girls your age? Every girl your age, this is the #1 sound you make throughout the school. That's it. History test. It's like I'm walking in the parking lot, just walking to class. They just hear. So true. Tune into it. Every girl, it's like, mom.
You sound like a.
That's how you ladies sound. Okay, let's tack for this. Okay, tack for. So it's a trinomial, 3 terms. So we're gonna break it into the thing. So here it comes. X squared equals 0. Okay, so far so good. Then we're gonna put here the 2x. The 2x has graduated back to black. And what multiply? You ask the question. Ask the question before you say the answer. Loud.
What multiplies to -27 and adds to 6?
Correct. What two numbers in this case?
-3
will
and
multiply to -27 and add to +6, and what does that become?
-9.
-3 and 9. Good. All right. So here is -3. Here is +9. That's good. Algebra 2, you're on it. And if you want to factor this out verbally, we can do that to check. Volunteer to do that. Someone else maybe? Volunteer to factor this out and check? Someone? Factor this just to check that this is the same as the following on the top. Check. X squared times x squared. X to the fourth.
Plus 9x squared.
Plus 9x squared. So what's plus 9x squared minus 3x squared? 6x squared. Finally, minus 27. Okay, so be sure to check your own work again. All right, good. So we have 3 factors so far. Can they be factored further?
No.
That one,
No.
yeah.
No.
You can't, right?
Why not?
This is a difference, but it's not a perfect square.
Yeah.
These are perfect squares, but it's a sum. So it's none of them are difference of squares.
So now we just solve for the solution.
Okay, good. We say if we have a 2-term thing, we have to look for a difference of squares. Difference of squares, right? Meaning difference, meaning a minus sign, and 2 perfect squares on either side. Is this a perfect square? Yes. X times x. Is this a perfect square?
No.
No. So it's not a difference of squares. Over here, not a difference of squares because it's not a difference.
Oh, so you can't do it if it's not minus.
Right. Has to be a minus. That's why the word difference is important. Difference of perfect squares. So we have 3 factors. What do we do with each of the factors? Solve by doing what?
Setting to
By
0.
setting zero.
Set to 0, correct. All right, let's bring it home. 2x, come on, equals 0. X squared minus 3 equals 0. X squared plus 9 equals 0. All right, rock on. First solution, divide both sides by 2. X is technically always going to be there. 0 is one solution. X squared equals 3.
Negative 3.
X squared equals
X squared equals 3.
X equals plus or minus the square root of 3.
Say it again loud.
X equals plus or minus the square root of 3.
Right. X equals plus or minus the square root of 3. That's right. And then this is from the previous problem. X squared equals negative 9. X equals
Minus
Plus or minus I.
plus or minus
3i. Equals plus or minus 3i. Okay, last person volunteer to list all 5 solutions. Go ahead, please.
Okay, so x equals 0.
0,
X equals square root of 3.
square root of 3,
X equals negative square root of 3.
negative square root of 3. Yeah, there's music.
X
in there.
equals 3i and
3i.
x equals negative 3i.
Negative 3i. Good job.
You wrong.
5 solutions. And if this were a graph, notice how many real solutions are there? 3 real solutions. This is a number, right? So if this is a number, it has 3 real solutions.
Even if it's negative squared.
Yes, negative. This is square root of 3 is 1.7. So it's negative 1.7. So if this is a graph, you guys, positive odd would go like this. Something like, we'll do that. Positive odd, 3 real solutions. And it goes through 0, a negative square root of 3, positive square root of 3. Something like that. That's what you can see. All right, further questions?
Does the degree rule always apply?
Yes. Degree rule is important. 5 solutions, odd.
That's so easy, because then you know if you're getting it wrong.
Yeah, you know if there's 5 solutions or not. It's good. Okay, thank you. Good job. Give yourselves a hand. Yay. Clap. I'm going to take this off. Woo! Thanks, class.
Nice hair.
Yeah, I went hat head.
A little.
Put it on again. Is it on still?
Yeah, it's on.
It's still on. Oh, it's still on. Embarrassing.